Hello everyone, today we will be talking about my homemade musical keyboard 3.0 with even more improvements compared to the previous two revisions. This is still the exact same device that I've shown in my past two videos, but it has been improved even more. So first of all, if you notice anything new, the lithium battery charging circuit is now completely gone. The connector is still there though. If you want to use a lithium battery, you're just going to have to use an external charger. And now I have used that space for a fuse, which will limit the current in case something shorts out inside, fails short circuit. And if the power supply can deliver enough current, then this fuse will blow open instead of whatever is shorted. Because that actually did happen to me yesterday. I was replacing the amplifier in this thing, and one of the transistors had failed to short circuit, and it literally went pop. A part of the packaging material had been flung away, and it was really loud, and this fuse will help prevent that. It is a fast 500 milliamp fuse, if I can get this thing out of here. You can see, come on, focus. It says fast 0.5 amps, 250 volts. So, that's nice. And let's just put this thing back in here. And now we will demonstrate it using a 9 volt. Dollar Tree 9 volt, of course. And if you can hear it, yeah, I'm sure you can hear it. It is quite a bit louder than it was before, and it draws less current. And the way that I have accomplished that is because normally this speaker right here, I thought it was a piezo buzzer, but it's actually a small speaker with a coil, so it actually does draw some power even when connected to DC. So the amplifier had a DC bias to it, so the speaker had DC voltage on it all the time, and it was consuming power, and it was getting warm. So what I did, if you look down below there, I added a capacitor in series with the speaker, a 470 microfarad capacitor, which is going to appear as an open circuit to DC, but will appear as a short circuit to AC. Even relatively low frequency, audio frequency AC that comes from this thing, it'll appear as a short circuit, so it blocks all of the DC that goes through. And I have replaced the dual transistor amplifier with a single transistor amplifier because it's simpler and it doesn't really need two transistors with this more efficient setup. And also, with this fuse, I can remove it and stick a 10 ohm resistor in series, which will allow me to monitor the current using my clamp meter, of course. It can measure DC voltage, but not DC current. So I am going to turn it on, prop it up using none other than a hot glue gun. Yeah, you can see that. It's on microfarad for some reason. We want it to be on voltage. And let's connect the battery up and measure the voltage across this fuse position while measuring the current. You can see there's already some current, which I think is the quiescent current of the 555 chips. This LED, it's a pure green LED, so it barely draws any current, and it's in series with a 5.1 kilo ohm resistor. And if I play a note, it jumps up to 0.28 volts. And if this was a 1 ohm resistor, this would be the actual current, but this is a 10 ohm resistor, so we have to divide the result by 10. So it's drawing 19 milliamps right now, and it's drawing 28 milliamps right now. It draws 27 or 28 milliamps whenever I play any note. And I think it drew quite a bit more than that before because the transistors in the amplifier were getting hot and the buzzer was getting hot. So this is a more efficient setup, and it also produces louder sound. Never mind that sound, that was just the fuse rolling away. Let me get it back. Okay, let's remove this 10 ohm resistor and replace it with the fuse because if something were to fail short circuit, this 10 ohm resistor would probably intervene, but it would probably just end up setting on fire, or whatever has failed short circuit would probably just explode. Anyway, that is about it for my third and hopefully last revision of my homemade musical keyboard.